Hello everyone. In this video, let us understand the design procedure of a two-way slab using STAAD Pro. Prior to that, let me introduce the definition. The two-way slab that we have considered is of dimensions 4 meter by 4 meter. It is resting on 4 beams, and all the 4 beams are resting on 4 columns. The cross-section dimensions of both beams and columns being 23 centimeters by 26 centimeter, and they are having equal lengths of 4 meters. Coming to the loads that we are going to consider, dead loads of the self weight of the concrete and floor tile weight or the partition wall weight as 1 kilonewton per meter square, and the live load considered is 2 kilonewton per meter square. And let's pay attention on the generally how we take the dead load. These are the general guidelines. The self weight generally ranges from 2.5 to 3.5 kilonewton per meter square for slabs of 100 to 150 mm thick, where the unit weight of concrete is considered as 24 kilonewton per meter cube. Floor finishes and partitions will range from 1 to 1.5 kilonewton per meter square, so that the total dead load typically ranges from 3.5 to 5 kilonewton per meter square for residential and commercial buildings. Now, the slab live loads are for residential buildings. The live loads may vary from 1.5 to 2 kilonewton per meter square, and for office buildings, 2.5 to 3 kilonewton per meter square. Commercial buildings or assembly buildings such as function halls or auditoria or cinema theaters, etc., ranges from 4 to 5 kilonewton per meter square, or it could be more. The storage houses such as godowns, warehouses, etc., it varies from 7.5 kilonewton per meter square, or it could be even. Now let us try to design using a STAAD Pro. Just click on the new project, select space, give the user defined name, slab design, and just giving us slab design. The units will be, force units will be kilonewton, and the length units will be meters. Click on next, and let this be add beam, finish it. You will get a grid because we are supposed to have a portal frame of 4 meter. So just select 4. Each grid unit is 1 meter. So 4, 4, and 4 equals escape. You can switch off the snap node by grid by clicking on snap node beam. So this is the portal frame. The intention is to repeat another portal frame of the same size. To do so, just select the portal frame, go to the translational repeater, select global direction as Z, and give default step facing as 4 meter, link steps, and that means steps will be linked, and we are not interested to link the open base because it should not get connected. That's why I've selected open base. So okay, now you got the frame. Having done this, next stage is to apply the supports. Go to the general, go to the supports, click on create, take all force and moments as add. Now you got the support. This support has to be applied at the bottom of the column. In order to do it at one shot, you just click on this view from Z, select this support, select a rectangle as a selection using the mouse. All the 4 nodes will get selected, and just ensure that it is assigned to selected nodes option. Click on assign. Done. Supports are there. If you want to see it, go to the isometric view. This is the isometric view of the frame, space frame. We have all supports got connected. Next, we are going to give the dimensions. General, go to the properties, or define, go to the rectangle, YZ as 0.23, just click add. So this is the cross-section dimensions of both beams and slab. Select this and select assign to view. Click on assign, it will get assigned. So all beams and columns will have the cross-section of 23 centimeter by 23 centimeter. In order to get the slab dimensions, go to the geometry, select create parametric nodes, and click add. You can give any user defined name for the popped up window. I'm just giving it as slab. Type could be either wall or slab. You can leave it as it is, or you can give it slab. You will get a cursor of this kind. Select the first node. Keep on selecting the nodes. After selecting the 4 nodes, again go back to the first node and then again select it. And after successful selection of the nodes, you will get mesh parameter popped up window, where the mesh method leave it standard and element type leave it quad, and also the boundary connectivity divide boundary segment to optimize mesh quality. Leave it as it is. Now coming to the target element, you can change it to 0.5 meter and the default number as 10. Just click OK. And there will be a dialog box which asks, do you want to add openings? We are not interested to add openings to the slab. Just click on no. Done. Now be aware, there is a button here, merge mesh. Meticulously click on this button. So we are done. And again, we have to give the thickness to the slab. That we can do. Go to the general. Go to the general. Go to the properties. Select thickness. Give nodes as 0.15 all. Let the material selected is concrete. Default, it will be concrete only. So again, select this red thickness and assign to view. Select the option assignment method as assign to view. Assign. Done. We have assigned it successfully. Now we have assigned the cross-section details. Now it's time for us to create the loads. Go to the load and definitions, select the load cases, add, take a dead load case where I'm just giving the folder name as DL, and also I'll be creating one more folder for live loads, LL, add. Under the dead load, I'll be assigning the self weight. So by default, the factor will be minus, and Y means vertical direction, minus means vertically downwards. Load will always acts vertically downwards. We all know it. So just click add. Having done this, under the dead load itself, go to the plate load. and give this load as -1 kilonewton per meter square and global Y, select it, add it. We are done with the dead loads, and similarly you create live loads. Just click add, go to the plate load, can do it as -1.5 because we are setting in the problem as 2. Let's set it as 2 -2 global Y, add it. So we have created the loads. Now we have to assign the loads. Self-weight. Self-weight will be applicable for both columns, beams, and slabs. So select assign to view option, assign, done. It is selected. Now live load is applicable to only slab. You just select it, assign to view, assign, applied, and sorry, dead load is assigned to the slab. Similarly, live load is assigned to the slab. We have done it. Now, successfully we have applied the loads. We can test with different combinations as suggested by Indian code. So in order to get the load combination, select the load case details, click on add button, and you will get load new load cases popped up window. From that auto load combination, you can select the menu item as auto load combination. From the select node combination code, let it be Indian code. Having selected this, just click on generate loads. The different combinations of loads, self-weight, live load, and dead load, with the multiplication of different partial factor of safeties and combinations, you will get it. Just add it and close this window. So you can see different loads are being applied. Now let's see the analysis of this. In order to analyze, go to the analysis and print, go to all, add, and simply analyze. So we'll get, if you want to see the output, you can see the analysis output. This for different loads, you will get the analysis. Now, final step is to design. Click on the designs tab over here and also concrete tab. In the concrete design whole structure window, select the relevant code, IS 456, the Indian code. Now, let us select the parameters that we are going to customize. There are a lot of parameters. The option is given to customize various parameters, out of which we are going to customize only compressive strength of concrete and compressive strength of steel. So these are the options selected. Just click on this button. It will get shifted to available parameters drop down list. Out of these two, my interest is to customize FC value, the compressive strength of concrete, and FI main value. These two I'm going to optimize it. Click OK. So now we have to define values for this. So FC, some default value is given. My intention is to have it as M30 concrete. I'm just giving as M30 concrete. Just add it as, and FY main, and also for secondary, I'll be using the same steel, FY 415. So I just added them. Now now it is time for us to select the various elements that we are going to design. So click on this command. So design beams, yes. Design columns, yes, I'm interested. Design slab and also the summary takeoff. So these things I have set. Prior to assigning these material properties to structural elements, let me show you the three-dimensional view of this particular structure using a 3D rendered view icon. You can see this icon. Just click on that. It's a 3D render view icon. Okay. I'm just closing it. So now coming to compression strength of concrete, I would like to apply for all the elements. So assign to view, assign. Similarly, 415 assign to view, assign. I am done. Now design of beams, select this. Carefully select the beams. For that sake, go to the select parallel to x-axis. These two will get selected. Another thing is parallel to z-axis. Parallel to z-axis, beams will get selected. Assign the selected beams, assign. So this is what we are going to design. Again, design columns. Go to the select. Assign to or parallel to y, columns will get selected. Let's say assign. Now design elements, assign to view, done. So we are almost done in assigning the properties and also the various commands for designing beams, columns, as well as slab. Having done this, finally, just go to the analysis and print. Just select all, add. This command will get added, perform analysis and print. Finally, just say run analysis. Right, let's see the output. The output for different loads and also concrete design for different loads you can see. And finally, this are reinforcement details, right? Finally, if you want to see the nodes, you can see the nodes of net quantity of concrete as well as steel. So that's all. It's so simple. Hope you have understood the design procedure.